All right, suppose we are trying to figure out what a to the second power multiplied by a to the fourth power equals. Well, that's just a matter of thinking about what a squared means and what a to the fourth power means. A squared just means a times a, and a to the fourth power means a times a times a times a. So we have a to the second power being multiplied by a to the fourth power, and we end up with a times a times a times a times a times a, which is a to the sixth power. Okay, if we did the same thing with a cubed times a to the fifth, it would be a times 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 a. So you have 3 factors of a being multiplied by 5 factors of a, and the result is 8 factors of a. So if you're multiplying something to a power times that same thing to another power, all you have to do is add the exponents. The rule looks like this: a to the m power multiplied by a to the n power is a to the n to the m plus n power. Piece of cake. Okay, now suppose we want to take a to the third power. Let's do this again. A squared, but we want to raise it to the fourth power. Well, a squared raised to the fourth power, something raised to the fourth power means it's being multiplied by itself 4 times. A squared times a squared times a squared times a squared. Each one of those a squareds is an a times a times another a times a times another a times a times another a times a. So how many factors of a do we end up all together? 8. So a square is multiplying by itself 4 times, producing a total of 8 factors of a. So the rule here is if a to the m is being raised to the nth power, it ends up equaling a to the m times n. And I suggest that's all there is to it. That is section, those are the rules required for section 8.1. Please read the examples in the textbook.